Hi, good day everyone. My name is Jason and I'm the group leader of the group 2. Today, we will be presenting our project titled Applying Derivatives and Integrals in Real-Life Context, which focus on analyzing student attendance over time. In this project, we will use calculus concepts such as derivatives and integrals to model, analyze, and interpret attendance pattern in a real-world scenario. Now, I will begin with the introduction of our study. First of all, this is our team. Now, I will begin with the introduction of our study. Calculus is not only a theoretical subject, but it is also very useful in analyzing real-life situations. In this project, we will focus on student attendance over time, which is something we can observe in real school context. To analyze this situation, we apply three main concepts, which are function, derivatives, and integration. The diagram below shows how a function works, where inputs are transformed into the outputs. In our case, the function helps us model student attendance over time. And the diagram on the right above shows the relationship between the differentiation and integration. Differentiation helps us determine the rate of change, while integration represents the accumulation. And both are connected back to the original function. Overall, this concept allows us to better understand the trend and behavior of student attendance over time. Next, I will explain the problem context of our study. Student attendance does not remain constant and it changes over time. It typically increases at the beginning and reach a peak and then decrease afterwards. As shown in the graph, the attendance follows a downward opening curve. The highest point, which is the maximum point, occurs at the day 6 with an attendance of 56 students. This pattern helps us understand how attendance behaves over time. It allows us to identify the overall trend, determine the peak attendance, and analyze overall student participation. Therefore, it is important to use a mathematical method such as calculus to model and better understand this real-life situation. Next, we define the mathematical model used in this study. This function AT represents the student attendance over time. Here, AT refers to the number of the student attending, while T representing time in days. This is a quadratic model which allows us to describe how attendance changes over a period of time. This model showed that attendance increased at the beginning. It then reached a maximum point, which represents the peak attendance. After that, the attendance began to decrease over time. This pattern reflects a real-life situation where participation rise, reach a peak, and then gradually decline. Mathematical modeling is important because it helps simplify real-world problems into a form that can be analyzed. It allows us to use mathematics to understand patterns and trends more clearly. In addition, it supports better decision making as we can make predictions based on the model. Overall, modeling helps us connect mathematical concepts to real-life application. Now I will pass the presentation to my group member to continue with the next part.
Assalamualaikum and good day to everyone. My name is Nur Syafiqah Naswa and I will be presenting Part A, Application of Derivatives, which focus on the rate of change. In this part, I will explain how derivatives are used to analyze student attendance over time. Specifically, I will show how we obtain the derivative step by step, interpret its meaning in a real-life context, and identify when attendance is increasing or decreasing. Now, let's move on to the first slide, which is the first derivative of the function. First, I will show how to obtain the first derivative of the attendance function step by step. The attendance model is given by a of t equals negative t squared plus 12t plus 20 within the interval from 0 to 10. This means the model describes student attendance over a 10-day period. To find the derivative, we differentiate the function with respect to time t. First, we write a prime of t equals d over dt of negative t squared plus 12t plus 20. Next, we differentiate each term separately. The derivative of negative t squared is negative 2t. The derivative of 12t is 12. The derivative of the constant 20 is 0. So, after combining all the terms, we get a prime of t equals negative 2t plus 12. Therefore, the first derivative is negative 2t plus 12. This derivative represents the rate of change of student attendance over time. In other words, it shows how attendance changes from one day to another within the interval from day 0 to day 10. Next, I will explain the meaning of the derivative in the context of student attendance. From the previous section, we found that a prime of t equals negative 2t plus 12. Now, we analyze the sign of the derivative. When t is less than 6, a prime of t is greater than 0. This means attendance is increasing. When t equals 6, a prime of t is equal to 0. This means the rate of change stops for a moment and the attendance reaches its maximum point. When t is greater than 6, a prime of t becomes less than 0. This means attendance is decreasing. In real-life terms, when the derivative is positive, more students are attending school compared to the previous day. When the derivative is negative, fewer students are attending. When the derivative is 0, attendance is no longer increasing and has reached its highest point. This helps us understand the behavior of attendance over time, not only as a mathematical result, but also as a meaningful trend in a real school situation. Finally, I will use the derivative to determine when attendance is increasing and when it is decreasing. We begin with the derivative. A prime of t equals negative 2t plus 12. To find the critical point, we set the derivative equal to 0. So, negative 2t plus 12 equals 0. Then, we move 12 to the other side, giving negative 2t equals negative 12. Finally, dividing both sides by negative 2 gives t equals 6. This shows that the critical point occurs at day 6. Next, we analyze the intervals within the domain from 0 to 10. From day 0 until day 6, the derivative is positive, so attendance is increasing. At day 6, the derivative is 0, so attendance reaches its maximum value. From day 6 until day 10, the derivative is negative, so attendance is decreasing. Therefore, the attendance increases from day 0 to day 6, reaches its highest point on day 6, and then decreases from day 6 to day 10. This analysis is important because it allows us to see the overall trend of attendance clearly across the whole interval instead of only looking at spread daily values.
Assalamualaikum warahmatullahi wabarakatuh to Madam Khairun and everyone. Today I will continue the explanation of what is integration. Integration in calculus represents the total accumulation of a quantity over time. In this case, we use it to model student attendance. Instead of looking at attendance on a single day, integration helps us calculate the total attendance over a period. The definite integral can also be understood as the area under a graph. This area represents the total accumulated value. So, integration allows us to move from instantaneous changes like daily attendance to a cumulative total over time. Now, let's continue how to calculate the definite integral.
The attendance function is given as AT equals negative t squared plus 12t plus 20. To find the total attendance from day 0 to day 10, we evaluate the definite integral. First, we split the integral into separate terms. Then, we apply the power rule to each term. The formula of the power rule is x power of n plus 1 over n plus 1 plus c. So, for the negative t square, we got negative t cube over 3. For 12t, we got 6t square. For 20, we got 20t. After that, we substitute the limits from 0 to 10 and we got negative t cube over 3 plus 6t square plus 20t plus c. Next, we apply the limits 0 and 10 to the negative t cube over 3 plus 6t square plus 20t. And we got negative 1000 over 3 plus 600 plus 200 minus 0. Finally, we get the total accumulated attendance, which is approximately 466.67 students day. Next, I will explain the interpretation of result. The result of the definite integral is approximately 466.67, which we can round to 467 student days. This value represents the total accumulated attendance over the 10-day period. It shows overall participation, not just the highest or lowest attendance on a single day. In real-life education settings, this is useful for tracking trends, measuring student engagement, and helping schools make better planning decisions. Next, I will pass to the next presenter.
Hi, I'm Teha. In this part, I will explain how to teach this concept using the graph, the common mistakes students make, and why real-life applications are important. So to explain this to students, I will start with the graph because it is more visual and easier to understand. The graph represents student attendance over time. From the shape, we can see that it first increases and then reaches a maximum point and finally decreases. Instead of focusing on formulas first, students can observe the graph directly. Then, we connect this to the derivative. When the graph is going up, the derivative is positive. When the graph reaches the highest point, the derivative is 0. When the graph goes down, the derivative becomes negative. This helps students connect the graph with the concept of rate of change. One common mistake is students cannot connect the graph with the meaning of the function and the derivative. For example, they may see the graph going down and think the number of students is negative, which is incorrect. Actually, it only means the attendance is decreasing. Another mistake is confusing the function and its derivative. The graph shows the actual number of students, while the slope of the graph shows the rate of change. Students also misunderstand integration. They do not realize that the area under the graph represents the total attendance over time, not just a single value in one day. These mistakes happen because students focus too much on formulas and not enough on the graph. Using real-life situations together with graph is very important in teaching calculus. When students see the graph as student attendance, it becomes more meaningful. They can imagine real situations instead of just abstract symbols. The graph also helps weaker students because they can visually see the increase and decrease instead of only relying on formulas. This makes learning more engaging and helps students understand concepts more deeply. In conclusion, the graph is a powerful tool to help students understand calculus concepts. By linking the graph to real-life situations, students can better understand increasing, decreasing, and total accumulation. This approach also helps reduce common mistakes and makes learning more effective. Thank you.
In conclusion, this project shows how calculus can be used to model real-life situations, such as our project, student attendance over time. From the graph, attendance increase, reach a maximum point, and then decrease. This narrative helps us understand the trend of change, while the integration allows us to find a total accumulated attendance. Overall, this project highlights how calculus connect to real-world application and help us to solve real-life problems effectively. That's all from our group. Thank you.